The tip from this is the National Oak Ridge National Lab.
Nice car.
Yeah, nice car. Yeah. So large scale additive manufacturing application in infrastructure. So here, manufacturing demonstration facility. Have you guys ever visited Oak Ridge National Lab?
No.
No? Okay, if you, I would suggest you can apply for the intern and for this national labs. So to get a one summer intern, and that'll be very, very awesome. One summer intern usually can result in this is the full-time job after you graduate.
All right, as long as I can put you down as my reference.
Yeah, I can give a reference. Yeah.
You be my reference?
Yeah.
All right.
Sure.
Yeah. I have several friends there.
Wait, really?
Yeah, I will let you know later. Okay, if you want to apply manufacturing related,
Okay.
because I'm a manufacturing. Yes. So.
Can I get that in?
This is a facility, so this is providing leading edge technology and business solution for industry. By the way, if you want to apply, you need to apply earlier. The reason is that you need to have undergo this security check. Yeah, several months earlier. So this is they have public and also private partnership, and there's a lot of active projects addressing technical challenges across the complete supply chain, reduce risk, accelerate commercialization of advanced manufacturing technologies while reducing life cycle energy. So this is their missions of this is a manufacturing sector. So here, big area additive manufacturing. So here is conventional manufacturing. Additive manufacturing, so the smaller, slower, expensive. The take days to go through 1 kilogram full. So the bigger area additive manufacturing is much bigger. So here is 1,000 cubic feet, faster, cheaper, and one machine can go through a lot. So the 1,000 pounds in a day. So here is the large scale. Additive manufacturing. Here is the process modifications. So here is material supply. Pellets is pellet. They are using pellets, not a fillet. A fillet is used to be melted, and so they can just put it into that way. They don't use the fillet. They use the pellet. Pellet is this pellet. Low cost injection molding process. Low cost and purchase the pellet. The big lot is 1,000 pounds. So use this one to buy a huge amount of you can buy huge amount of this is the projects. So process modification extrusion, you can extrude this one to get a single screw extruder instead of the heated nozzle. So here the development timeline. So from the signing to technical demonstration in front of these people about 7 months. And so here is the Oak Ridge National Lab. And so this is the Cincinnati INC here. And you can just take a look. Okay, so here is the timeline, development timeline. So here is a large scale AM distribution map. We have a lot of this network there, research institutes, production facility, service bureau, a material provider, along with the equipment, the manufacturers. So here is a high-speed, high-profile demonstration. You can see this is a high-speed, high-profile. So here you can take a look. Okay, if you are interested, because the time is limited for our class. If you are interested, you can just read by yourself. So here's a printed Cobra, first finished parts. So here's a locomotor, static, first 3D printed car. This is they printed this part. This is printed Jeep. This is printed car and house. They printed car and house. So the printed composite tooling for this is the NAVR, this high temp is the material. So printed wind tunnel, wind turbine mold. So here is a trim tool for Boeing. This is Genius is largest polymer printed object. So this is a very important. You guys take a look. Okay. I will not read here. This is automated construction seed money proposal. In the purpose of research, robotic manipulators will automatically fabricate structures using a combination of small generic building blocks, bonding agents, tensile members, and castable and extrudable materials. So the structure will be built up using a robotically controlled extrusion nozzle that deposits rapid hardening paste in thin layers until the desired shape is achieved. Many plastics, mortars, and foam materials have potential for this kind of fabrication technique. So this is robotically applied in the stucco fashion, where with ventilation ducts and drain piping will easily be incorporated into or become part of the structure. So this is envisioned enhancements to conventional construction. So this incremental deposition construction offers additive potential advantage. So more durable, less expensive material, optimized material usage, and just as I show you guys the industrial arm and people use in the on the moon. Improved thermal resistance, superior strength to weight ratio. Freeform approach allows incorporation of complex geometry and direct transmission of computer-based design information directly to deposition the control. So you can see how important it is to use a computer. The 3D printing the concrete, you can see. This is very similar to that one I showed you for this 3D printing. It's called contour printing. This is a print. You can print this circle, and you can easily print a house. You print a building. So as long as you have the comparably large, this is probably the large it does robot. Nozzle, the nozzle and the material supplier, and so then we have this is industrial arm and industrial rovers, the arm, we call it industrial arm also to control. And how to control and you need to program. So this automated freeform composition. It is automated and they use the industrial arm robots. So rapid progress in plan. You can see. So here is the frame, and here is the industrial robot. And we have a very good prototype system. And for this one, alpha and CBAM and beta CBAM and BAM-P. And we have done a lot of good work. So infrastructure projects, the direct manufacturing, so it's many buildings for to build the houses. Direct manufacturing, AMIE manufacturer how to print a full-scale building, and the design Miami printed pavilion. We usually see a lot of pavilion in the parks. And ACES project partnered with the CERL, the Army Construction and Engineering Research Laboratory. So indirect manufacturing, the Domino, the sugar project, and we have done this one. This is the partnership with the BIT and precast concrete. This is a company, private company. So here is the build. This is the building, integrated, additively manufactured integrated energy. So concept is to integrate energy of building and transportation using AM. The house has great solar and energy storage. It's very awesome. The car has natural gas, hybrid electric, and two-way wireless power transfer between vehicle and building. And from concept to reality, it takes about 6 months. So this is very good, right? I want to have this one in my backyard. So any of my children, they are not following instructions. I just put them there instead of staying in my house. What if they call the police? Will police arrest me? No, okay. Okay, so you can see we build this very quickly to this model. Project additive manufacturing integrated energy. You can see what is important. So the nozzle, the nozzle, and also this is how to control the nozzle. Layer by layer. Wall is okay, almost done, right? Very awesome. Here is an application, IES demo concept. So here is this will just show. It's very, very beautiful picture. And so they also want to print using these bio-derived composites. For example, I'm printing with the bamboo. The bamboo is the bamboo. I don't know. Are there any bamboo trees in US?
I don't think so, because
It depends on the weather, right?
it depends, but most of the bamboo, well, there are bamboo plants in houses, but I don't think growing in the wild.
They're just, they're here, they're just
They're
not
here.
native.
It's not native, they're imported.
People planted them.
There's bamboo by the zoo.
Yeah, you
Oh, yeah, there's bamboo at the zoo.
ever went to the panda exhibit? Come on.
Yeah.
But in China, in the southern part of southeast part of China, and there are a lot of the wild bamboos. You know pandas, right?
Yeah.
The giant pandas, the very, very fast.
Yeah,
very
they're so
sunny.
cute.
And these guys can only eat Chinese bamboo.
Oh.
Any other food, they will die. That's the reason the panda is almost extinct.
That's all they can eat?
Huh?
That's all they can eat? You said it's just bamboo?
They just eat the bamboo,
The China bamboo.
Chinese bamboo. So that's the reason the panda is almost goes through extinction.
Yeah.
But also, the panda, when the panda is born, it's just how small it is. The sun. Just like the sun.
I heard they're super aggressive.
Yeah. So because they have the very, very high requirement for the food. And so that is the reason it's very, very, very difficult to survive. You know the pigs, right? The pigs can survive very well. Why? They can eat everything.
They eat their own stuff.
I'm kidding. The survivability. So the bamboo, okay, these are different. So this bamboo, they use the bamboo printed from bamboo reinforced PLA. So this is polymer. Create a structure that with the bio-derived material that withstands Miami's heat, and this is in the Florida humidity and salinity. This is salt. The project used so many kinds of materials. Bamboo has a low CTE than plastic, and thus acts as a reinforcement, is allowing researchers to build large parts with less distortion. So this is very, very good material. So here, design Miami pavilion. Pavilion, we see a lot of pavilion in the parks. Was commissioned by the Design Miami for its annual meeting and was moved to the Miami Design Suite to house an outdoor culture program for the next 2 years. So this is they built this kind of thing. So in order to operate this machine, you must know how to operate. This is robotics. Robots. We have industrial robots in the basement, underneath the dean's office. And the senior, that's the senior course. I'm going to teach you next year. Next for 2023, I will teach you. I will come back from China. Okay, let's see here. Including these countries.
You said you're going to China next year?
Spring 2023. I will have sabbatical. So here is the Army College of Engineers Construction Engineering Research Lab. Working on this one on the prefabricated inserts for enabling the printed concrete sculptures. This is very awesome. And so this is a 3D printed layer. 3D printed layer. So here is a gate precast concrete mold inserts. This is very good also. Okay, it's very nice building here. Here, you want to do these kind of things. This is a 3D printed, very good. So here you can show again how to operate this one. 24 hours, less than 24 hours, you can accomplish it. You can finish it. It's very beautiful thing. All these they are the industrial robots. And how to program industrial robots is very awesome. This inspiration for large scale field able printing. They printed this one.
You ever seen the 3D printers that like they come out out of like resin and they print it into resin?
Yeah, they print.
You seen those? Really, instead of like it's not like layered printing, but like they pull it out.
That is selective 3D printing.
So, yeah.
And you use a laser or any other the heat generated device.
Yeah.
You melt some parts that you desire, and then after it solidify, you can just pull it out. Yeah. So they're different than the 3D printing. So here, also this is a tower and build this tower. So you can print this tower also. So future work and the people given them, so you can see this large robots where they can build. Oh my God! So as long as you have the very big arm, and you can build everything theoretically. Right? So here, researchers as MDF are currently working on creating a plain, large-scale, portable stabilization system that will allow for full-scale automated construction of buildings. Implemented with conventional construction equipment and quick setup, minimal set of preparation. This is very awesome. Thank you very much, guys. That is so very beautiful picture, right?
It's pretty.
Yeah, very beautiful picture. So here is if you are interested and